Okay, let's talk about some derivatives for logarithmic functions. In this video, we'll talk about the basic logarithmic functions of base e and then general bases. And then we will talk about other types of methods for logarithms and derivatives in a future video. So the derivative of the natural logarithm of x is where you start. That's kind of like the beginning or the most basic of logarithmic derivatives. Its derivative is simply 1 over x. What if the base was not e? Similar to the exponential derivative videos, we can adjust for the fact that it's not a base e. For example, here we have base b. And the way we do that is by taking the reciprocal and multiplying by the natural logarithm of the base in the denominator. So that ln b in the denominator adjusts for the fact that the base is not e. What if we had the logarithm of some function of x? In this case, we still have a reciprocal, but we would apply the chain rule. For compactness, I like to just write it as follows, where we have the derivative on top of the original function within the logarithm. So f prime over f. And what if the base is not e? No problem. Apply the similar property from the previous example. So we have the function, its derivative on the top, and then we would adjust for the fact that the base is not e by using the natural logarithm of the new base. We can use that logarithmic rule right off the bat to derive this. But anyway, it depends on how you first have been exposed or instructed. Generally speaking, though, this particular formula encompasses all the previous ones and is really your reference point for doing these questions. Here's our first example of 5 that I will do in this video. In this case, we have the logarithm in base 3 of x. Well, how do we approach the derivative? Well, the derivative of the logarithm is 1 over x. And we adjust for the fact that the base is not e by taking the logarithm of the base 3 here. In the next example, we have the natural logarithm. So no need to adjust for bases here. We simply just take the reciprocal, which is 7x plus 3, and then apply the chain rule to that. So the derivative of 7x plus 3 is 7. And I can just put that in the numerator as such. Moving on to the next example, we see that we have an exponent 10. This 10 applies to the brackets, not to the logarithm. So we can use one of the rules, which is the power rule for logarithms, and bring that exponent to the front. And we write the question as follows. And we would have here 10 ln of 2x plus 3. Then we take the derivative. So in this case, we would have the derivative of ln of 2x plus 3, which is the reciprocal of 2x plus 3, multiplied by the derivative of 2x plus 3 in the numerator as such. We can simplify this further by writing this as 20 over 2x plus 3. And I'm just going to apply a little hack there. Hopefully nothing too dangerous, but there is your derivative. Okay. Let's try another example here where we have a base 5 and we have a chain rule that needs to be applied. So first we want to apply the reciprocal rule. So this will become 8x squared plus 3x minus 1 multiplied by the derivative of 8x squared plus 3x, which is 16x plus 3. And then multiply the denominator by the natural logarithm of 5. And that's your final answer. In this last example, I have here log of 9x minus 1. Now, it's really important that you pay attention to the audience and to whoever's asking you the question, because sometimes, or most often, I know that logarithm is in base 10, but depending on what your area of study is, for example, in computer science, or if you use math websites to do the code to check your work, log x is often interpreted as natural logarithm. But just be sure to ask wherever you are getting the question from, do they mean base 10 or do they mean base e? In this case, let's just use base 10 and proceed with the familiar approach, which is to take the reciprocal and deal with it as if it's in base 10. So here we go. We would have 1 over 9x minus 1 multiplied by the derivative of 9x minus 1, which is 9. And then we need to multiply the denominator by ln of 10 to adjust for the fact that the base is not e. And there you have it.